So in this video, I want to go through how you can use a tool, a free tool called Gephi to do network visualization. So Gephi, as I outlined in our workshop series, does a lot of things, but I really want to focus on the network visualization aspects of it. And so we are going to do some network visualization on a data set that we acquired via Twitter. So this data was received from the Twitter API, and essentially it is information related, tweets related to the migrant caravans that were occurring in Central America. And so they've been occurring since 2016. And if we take a little bit of a look at the data set, you can see we have about 100,000 or so. Yeah, so a little bit over 110,000 tweets that were all gathered using one hashtag. So the Caravan Migrante hashtag, which was a prominent hashtag throughout the time of the various migrant caravans that were happening over the last few years. And so this data set has a few different fields in it. It has the ID of the tweet, the ID of the user name of the person tweeting, other information like when the tweet was created, the larger conversation ID, the actual tweet text itself, then some statistical information. I apologize, this is probably relatively small on your screen, but some statistical information like retweets, replies, and etc. And then it essentially has two fields, a couple of fields that are very useful for building a network visualization of all of this information. And so we have a field for replied to user ID and replied to username as well. And if you just scroll down, not every one of these tweets has a reply. So if an individual had just, tweeted something themselves, not in response to another individual, this field here will be blank. But if you kind of quickly scroll through, you will see that there is a variety of different user IDs in some of these fields when the case of when the person has actually responded to somebody else. And so we have this rather large data set, and we want to, from this, try to get a better sense of some of the aspects of the network that might have been created around this hashtag. So using something like network visualization, we can get a better sense of who the more influential tweeters might be. We can also get a sense of, how different kind of communities may have been created within this data set as well. So there's a lot of really interesting kind of statistics or kind of features that we can determine from this larger conversation using network visualization. You could probably do something like this manually on a smaller data set, but again, when you get up to 110,000 different tweets, that becomes far more challenging. And that's where a tool like Gephi and a concept like network visualization really makes that process of getting information, network information from a large data set far more useful. So essentially, to use Gephi, you need two data files. You need your nodes and your edges. And so your nodes are essentially the people or individuals or things that are going to be participating in your networked conversation. So in the case of our Twitter data set, this would be the Twitter user IDs and the corresponding Twitter handles of the people that are participating. Every single person who happens to be tweeting in our data set would be represented in your node file. And we'll look at an example of this in 1 minute. And then the second file you need is your edges. And so this is essentially the source and the target of the edge. And so you're trying to get a sense, you need a file that essentially has the person who is tweeting and the person that they are tweeting to in one CSV file. And so again, the source is the person that is tweeting and the target is the person that they are replying to. And from these two files, so your nodes, who essentially are your Twitter conversation participants, and your edges, which is essentially the connections or the tweet connections between those two individuals, you can really build a interesting network visualization of how people are participating in this conversation related to the migrant caravans. So let's look at the files a little bit. So we already looked at the larger data set, but let's just open up and I'll make this a little bit larger. But essentially and this is one challenge with network visualization, is that you may have to take a data set, like this larger CSV file that has a whole bunch of information in it, and kind of tailor it for what the software needs. And so in this case, Gephi doesn't need all of the information that you have in this larger data set. And so this is an example of the nodes file for our migrant caravan data set. And it's relatively simple. It's only 2 columns, a column for ID. And you can see here it's the user IDs of the different people that have participated in our Twitter conversations, and then a label. And then in this case, the label is essentially the Twitter handle for all those individuals. So this helps because the user ID, the numeric user ID, isn't always that useful. It's nice to have, in the case of Twitter data sets, to have the username handle as well, because then you can take a look a little bit more easily about who these individuals are. So if you find out that one of these nodes is a particularly influential user within our data set, it's nice to be able to just take their handle and look them up on Twitter. That's a little bit more challenging, not impossible, but a little bit more challenging with just the ID alone. And depending on your data set, depending on what you are doing network visualization on, there could be more here. It could be a full name, a whole bunch of other things. You can actually have a variety of different fields as well, but essentially the nodes file needs to have at least a unique identifier for every single one of your participants in a network conversation, and then some further information about those individuals. And what that further information is will really depend on what you're doing. So in this case, all I really need is their user ID, which is unique in the case of Twitter, and then their handle. But depending on what you're doing, if, for example, you were doing a network visualization on university professor citations related to publications, you might have their first name, their last name, maybe their institution. So again, what you have in this nodes caravan might vary, or nodes file might vary a little bit, but the only thing it has to have is a unique identifier for every single user, and then you would usually have some additional information. But it really depends on what kind of network you're working on, what that additional information might be. So that is the nodes file. And then the second file obviously is going to be our edges file. And so the edges file requires both a source and a target. And so this is a CSV file. So you'll see the source, which is the person that is being tweeted, who is doing the tweeting. And then the target at the very end of each line is the person who is being replied to. And that source and that target, those 2 columns are required. And so you basically you can put other things within your edge data set, but you need to have both a source and a target, and it needs to be formatted this way. So a capital S and a capital T for target. And then in this case, I've included a little bit more information. I've included the tweet text. And again, like our nodes caravan, that nodes file, what you might include in this CSV file might vary. And so in my case, I thought it would be interesting, or at least useful, to be able to also potentially visualize what the actual tweet text was when you're looking at the graph. But you only really need the source and the target within your edge file, but you may again want to include a few other things as well. And in this case, I thought it was useful to include the tweet text. So essentially you have now 2 files. You have your nodes and your edges. And again, as I said, the challenge is that you are going to have to prepare your data set to, have, this kind of formatting. And so I've done this using a small Python script, which we'll learn a little bit more about Python in our 3rd class. But you could also do some of this manipulation in something like Excel as well. So for example, you could, create a CSV file of all of the unique usernames and user IDs from something like our larger data set. But the key takeaway there is that you have to have this work, I guess, Effectively within Gephi, you may have to take your larger data set, as we are looking at like right here with all of our tweets and all of our information, and filter it a little bit. In particular, you would need to filter it so you have some file that has every unique participant within this larger data set. And so you could do that via Excel if you're comfortable with that. You could maybe even do it with SPSS, but I've typically done it using Python, and it's just a relatively short script that gives me a file with only unique user identifiers, this column here, and also their corresponding username as well. So just know you have to do a little bit of preparation to get your file ready for Gephi. So now that we have our data sets relatively prepared, let's switch over to Gephi and start the early steps within the network visualization aspects of what we're trying to do. So when you first start Gephi, you'll see a little kind of welcome screen. We'll close this because we will essentially, the first step when we want to do network visualization is going to be opening up a new project. So we will go to File and the New Project. And you will see here a little workspace, and that's a little tab here. You can have more than one open at a time, but I usually just try to keep one open just so it's not too confusing. So now we have essentially an empty Gephi project, and a lot of things on the screen right now, but essentially what I always do in the very first step of my preparing my network visualization is importing the data. And so as we saw, we created our node file and our edge file, and we want to import those both into Gephi so that it can start doing some of that visualization. And so to do that, you would click on, if you're not already on that screen, you often are when you open up a new project, but if you're not, click on the Data Laboratory tab, and then you'll essentially see kind of an area here in the middle where you can import in your data. And the key step is to click on Import Spreadsheet. And I always start with the nodes file. I find that works a little bit better because then it essentially knows who the people are participating in your conversation. So again, this is on my desktop. So I just select the CSV file that we looked at a little bit before, and then I click Open. And there's not too much you have to do with this. You essentially can get you can validate that everything looks good with your data set. So we can see here that we have an ID and a label, and they're separated by a comma. If you need to, for example, change the character set of the data that you're looking at, you could do that here as well. And you want to make sure that it's imported as the nodes table. So if this said something else, you want to change it. That's why I usually do the nodes table first as well. I think it defaults to the nodes table, but just make sure that this says nodes. But your file here looks relatively good. I mean, this is just a subset of the file, but we can see here that our IDs and our labels are in two separate columns, so everything looks relatively good. And then we'll just click on Next. And we want to, in this case, import ID and label. If you had some other data, columns in there that you didn't want to be part of your data set, you could click or unclick the options here. But in this case, because I kind of prepared the file the way that I really wanted it to, everything is good. So then we will just click Finish. And then it gives you a little bit of a report. I don't really play around with any of these things too much. You can see here that we had 34,000 different nodes. So within our data set of 110,000 something tweets, we have 34,000 different participants. And again, we created that file from scratch. So you may at this stage want to just double check that it matches the number that you had within your data set. The one thing I also like to do is append to an existing workspace. So I click this from new workspace to append to existing workspace. If you don't do that, it opens up a brand new tab and a new project. And so or a new workspace. So I just do append to an existing workspace so you don't have a whole bunch of extra tabs up here, and then click OK. And then essentially you will have your data available within your node data available within Gephi, and you can see it displayed here. And if you ever want to go back to it, you can just click on this node option here. So we've now imported our nodes, so we know this is, again, is essentially a list of people who are participating in our larger network conversation. We want to build our network visualization. We need to have the information of how these people are communicating back and forth with one another. We can't just have who is participating. We need those, back and forth conversations. And to do that, we need to import our edges file. So we go again to import spreadsheet. And in this case, we select our edges CSV file and click on open. And it'll look pretty similar to what we saw when we imported in the nodes. But you'll see 3 columns, and as I said before, 2 of those columns, one has to be labeled source, one has to be labeled target, and whatever other information is that you may need can also be there as well. And again, you want to make sure that it says import as and its edges table. It does this by default, starts with nodes, then switches to edges, but you want to just make sure that is set up there. So everything looks good. Our CSV file seems to be separated into clear columns of source, the actual Twitter text, and the target. And then you would just click next. If you want to import additional strings, this is where you would do it here. So for example, again, if you had more extra columns for data and you didn't necessarily want to import them, you can select and deselect them in this view. And again, it doesn't allow you to not have source and target because those are required. But if we had this tweet text and didn't need to use it, we could unclick this. And if you had more columns, you would see more things here. And you can also specify the data format as well. And so in this case, it's the string, and I think it automatically recognizes them. But if you saw something weird here and it was supposed to be a number and it was listed as a string and you wanted to keep it as a number, you may have to play around with this little drop down as well. But otherwise, everything looks good, so we will click on Finish. And again, I won't go through all of this, but the only thing that I typically change on this page is, again, I want to append to an existing workspace. We don't want to create a separate workspace because then we wouldn't have a connection between our nodes, so our individual participant data, and our edges. And so just ensure that you switch this to append to existing workspace, particularly when you add the edges. And there's a few other things you can change here. You can play around with them a little bit. Self loops are when somebody kind of replies to themselves, in this case anyway, with Twitter data. And you may or may not want that, but I will keep it in. I generally keep everything as is, except for appending it to the existing workspace. So then we click OK when we're all set up here. You can also specify a directed or undirected graph type as well. So a directed graph has conversations that show some form of directionality. So if you are tweeting to someone, that has a form of directionality. But if your data set network visualization, it did not matter whether there was a back and forth kind of reciprocal network, you may want to switch to undirected. There even is some cases with a data set like this where you want to have it undirected. But for the most part, if there is some, network aspect where somebody is communicating to one another and that person can communicate back to them, you want to keep it as directed. And essentially what it'll do, it'll create a graph with little arrows that show us the directionality of the edge. And so if a person, like I said, is replying to an individual, those nodes will have a little arrow that points to the person being replied to. So just know that you can, within Gephi, set up both directed and undirected graphs, and you specify that when you import in your edges file. So let's just go OK and keep it as is. So there you go. So we have our nodes, and if we click here, we have our edges as well. So we essentially have a list of all of the different sources and targets. So this again, in this case, it's the source is the person doing the tweeting, and the target is the person that they are replying to. And we have some extra information here as well if we need to use it for our tweet text. And Gephi does a little bit of calculations that we won't worry about too much right now. But essentially, we are all now set up to do our network visualization. And so we have all of our nodes and our edges imported into Gephi. So now that we have our nodes and edges imported into Gephi, we obviously want to do some form of visualization with them. We want to see this network represented in a graphical or a visual way. So to see, I guess, our visualization in our early stages, we would click over to the Overview button here. So we click on that. you will see this relatively not helpful big giant square of, it's actually made up of little circles. It's hard to tell because they're all one big thing. But this is often what you get by default once you've imported in your data to Gephi. And if you want to, I guess, move from something which is more useful, you have to use what are called layouts. And they're listed here in the kind of left-hand column of the of Gephi. And there's a few of them, but there's two that are more often used. And so these are all kind of different algorithms that will control how your network visualization is spaced out. And so it isn't necessarily changing the underlying data, but it is taking this big giant square and changing the layout in an algorithmic way to make it more visually meaningful. And so there's a couple, I'm not going to go through every single one of the different layouts that is available here, but often in particular with larger network visualizations, Force Atlas is a particularly regularly used one. So we'll click on Force Atlas 2. That's, again, there's two versions of Force Atlas. The second one was made to be a little bit, work more efficiently over larger data sets. So we will click on Force Atlas 2. And then there's a variety of different settings within Force Atlas, but we're just going to stick with the default settings for now. And we're going to watch and see how this big black square that we have here changes as we run it. So again, between the different layout options, select Force Atlas 2. We'll keep all the defaults for now. And then we will press this little run button here. And you'll start to see, and we may have to zoom out a little bit, but you'll start to see that our network visualization starts to take shape a little bit. Again, depending on the speed of your individual computer, this may take more or less time, particularly if you're working on large data sets. It can be very slow. These algorithms are processor intensive. So if you're running this on a laptop that's a little bit underpowered, it may take more time, particularly if you're doing a larger data set. And so this data set has 100,000 different tweets in it. And I think there was 35,000-ish edges, as we saw. So it's pretty big. And what you will notice is that this algorithm keeps running. It will never stop per se until you push the stop button. So when it gets to a point where there's not much changes going on in your data set and your visualization, feel free to press stop. And so it seemed most of our changes happened in the early stages. So I think we're in pretty good shape now to press the stop button. And you can see that it's now the visualization is not changing anymore. And what I'm doing here, when I'm zooming in and out, I have a 2-button mouse with a scroll bar in the middle. I'm just scrolling back and forth with the mouse to zoom in a little bit. But you can see that we have a little bit more of a more useful graph now. And so we essentially have all these dots, which are individual nodes. So again, these represent people tweeting to one another or individuals. And then we have these different lines that are, pointing to the nodes. And so, for example, in this case, this dot represents an individual, so a person in our data set, and they have tweeted to this dot here. Similarly, this person over here has tweeted to this person as well. And you can see, because we did it as a directed graph, there is a little arrow that indicates the direction of, in this case, the communication. So this person is replying to this individual. This person is replying to this individual. This node here has not done any form of reply to either of these individuals. And so again, that is, I guess, shows you a little bit of the directionality of this graph. But you can see, we'll do more work on this in a little bit, but you can see, I guess, a sense of some of the network aspects of this. And so you can see that there's a cluster of tweets here, which is probably, it seems to, without doing more work on this, and that this particular node, this particular individual was a particularly influential person because they have a lot of, they're tweeting out to a lot of people, and there may be a lot of tweets towards them as well. But you can get a sense of some of the aspects of these networks. And these ones kind of outlined here on the outside are mostly individuals that have just sent out a tweet with no reply. And so as you may have recalled from our data set, we had not every tweet had some form of reply. So we have some of these outliers out here on the outside edge. Not all of them are. But I think in a lot of cases, these are just individual tweets with no actual reply. And so what you might have wanted to do with your data set is just had replies or things like that, or not had anybody without any replies. But just know that there are some conversations happening here on the outside that are not as significant. And I won't go through all of the details in this little workshop video, but there are some ways to filter out what we see a little bit to just focus on the conversations where there is more participation. And so if we have a little bit of time near the end, I'll go through that as well. But just know that the main thrust of the network conversation in this visualization is happening here in the middle. And these outliers are kind of smaller, more isolated conversations, oftentimes somebody just responding to themselves or something to that effect. So, this is not bad, but there's a couple of things that we can do within the Force Atlas layout itself to make some of this visualization a little bit easier to comprehend. And one thing that I like doing is the prevent overlap option. So you can see here, again, on the left-hand side. And what you see here will vary depending on what layout algorithm you've selected. But one of the nice features of Force overlap with Force Atlas 2 is that you have this prevent overlap option. So we can just run this now that we've clicked that. And you will see the little dots move out a little bit. And so it's trying its best, and it's not perfect, but it's trying its best to separate the dots that overlap from one another. So there's not much changing now. So let's press stop. And you can now see to a certain degree that this community that might exist here isn't as dense as it was before. You can see a bit of the individual dots in a way that was a little bit more challenging before. So that's one option that you can use. You can also play around with the gravity options as well. So for example, it's maybe this gravity here is set to 10, and essentially the larger the gravity, or close the gravity is to 0, the more it attracts the nodes to the middle. So if we were to set this to, let's say, 10 and then run it, you can see they're splitting up a little bit more. Still not great, but you have a little bit more separation. So we click stop there. One thing we may want to do is change the size of these little circles. And so a helpful thing to do with a network visualization is have the size of the circle change depending on whatever statistics you might want to use. And so there's a variety of statistics that we can calculate using Gephi. And then once those statistics are calculated, we can use those statistics to determine the size of our individual nodes. So these little circles, for example, you may want a circle to be larger if more people are kind of interacting with it. So again, you would see that perhaps the more influential individuals within our data set would be larger. And so you could, I guess, more easily see the nodes that are significant, and the smaller ones, like on the edge here, that don't have much participation to it, would be smaller. So as I said, to get that, we have to calculate some statistics on our graph, and Gephi makes this relatively easy. So you may, look over here on the right, and you can see a couple of, within this statistics tab. So just make sure you're on this tab. There's a filter tab and a statistics tab. To actually run these stats for the entire graph, you will just click on any one of these individual buttons. And so we're just going to do a couple. We're going to do average degree. We'll run that. And you get a little pop-up of the degree. And so the degree is essentially it can be the amount of people connected to an individual node. And I'll go through some of these in more detail in a minute. But the degree can be a simple measure that is pretty effective because the degree essentially is higher or lower depending on how many people are, in this case, how many edges are connected to our node. And so in this case, with our Twitter data set, the degree will be higher for really active participants in a conversation. So if they are getting, if they're tweeting replies to other people and also getting replies back to them, so degree in this case is both, they will have a higher degree measure. You can also do in degree, which is replies to a person, and out degrees, which is a replies away from a person as well. So you have a couple of different ways to do degree in this case. So we've done degree, the average degree. We'll do a couple other ones. We will do the network diameter as well. So we'll run that. And we have to specify whether our graph is directed or undirected. And it gives you a little bit more information about which each one of the, when you click on this, it'll calculate some measures, and it gives you a brief background on which of them are. So betweenness centrality is a common one, closeness centrality is another, and eccentricity is another. And we'll go through these in just 1 minute, but know that when you click OK and run this, it's running all of these statistical measures at the same time, and then you can use all of them individually when you try to change the way that your nodes actually look. So we'll just click OK for now. And then finally, well, when this is complete, it sometimes takes a little bit of time. Network centrality, you can see it kind of proceeding here. Network centrality is a little bit more of a, I guess, a processing intensive calculation, but it's almost done. And then you get that same little graph. I often don't pay too much to it. We'll close that. And then finally, we will do modularity as well. And so we'll look at how we can use this in a minute, but modularity essentially is useful if you want to group your nodes into individual communities. So if we click run, and I always just leave these as is, and then we go OK. And again, it'll take a little bit of time. This one was relatively quick. So now when you've actually run them, you can see little measures beside each one of them. And you can see that they're it's probably a little hard to see, but you can see there's a little blue question mark. So you can view that report that we saw again if you needed to. So now that we've actually, let's look a little bit, let's very quickly look at some of what those statistics mean that we just looked at. So I'll just go through this relatively quickly. I know nothing about this organization, but I found this blog post a really great explanation of some of the different statistical measures that are available in Gephi and what they mean. And so the simplest one, as we saw here, and I'll share this link within our workshop page for this week, but the first one, as we saw, was degree centrality. And degree centrality essentially assigns an importance score based on the number of links held by each node. So for example, if a person is both replying to individuals and having people reply to them, that will have a high degree. And as it says here, what it tells us is how many direct one-hop connections each node has to another network. And it is useful for finding connected individuals, so popular individuals and individuals who are likely to hold information, or individuals who can quickly connect with the wider network. So again, it's probably the most basic measure, but it can be pretty useful, particularly if you want to see somebody who appears to have a lot of conversation related to them. Another commonly used one is betweenness centrality, and it essentially measures the number of times a node lies on a path between other nodes. And this will tell us essentially which nodes or individuals are bridges in the network, and so it can be useful for finding people who kind of shape the conversation around them. And so they aren't necessarily the people with the most activity per se, but they are the people that are kind of, maybe not so much gatekeepers, but people that connect communities to one another. And as it says here, it's useful for analyzing communication dynamics, but should be used with care. A high betweenness count could indicate somebody holds authority over different disparate clusters in a network. So they're in the periphery of both clusters. And so if you were interested in seeing the individuals who bring communities potentially together, this would be a good measure. Closeness centrality is another one. Centrality of scores based upon the closeness to all other nodes in the region, the network, sorry. And you can use it for finding individuals who are best placed to influence the entire network quickly. it says here, closeness centrality can be good to find a good tool to find broadcasters. But in a highly networked network, you will find all nodes have a similar score. So again, may not be that useful. There's more here. PageRank I'm not going to go through it, but it's another method that was often used in search engine algorithms as well. So again, if you want more information about all of these different calculations, I will share this link. But know they all exist, and you can use them as a tool to change, I guess, the way that your nodes look within Gephi. Now that we have all of these statistics organized, let's change the way our graph looks a little bit using these measures. And we'll just stick with a simple one. We'll use a degree-based one. But let's say, as we said before, we want to change the size of these little nodes based upon the degree measure. So how many people are kind of communicating back and forth with a person. We want the nodes with a high degree calculation to be bigger and the ones with smaller to be smaller. And so you can change your appearance of your graph in a few different ways using, again, in the left-hand column in this little appearance tab. And so we will go to this thing that kind of looks like a series of little circles in a row here. That's essentially allows you to change the sizes. And we will stick on nodes. It should be selected by default, but we want to change it by node, make sure that it is. And then we will switch to ranking. So you have a unique and ranking, and then we essentially want to choose an attribute. And so in this case, because we have done all of these calculations, these different attributes are available. If we hadn't run the calculations over here, all of these different options wouldn't be available. Because they are. So we'll click degree, and then you can play around with the size. We'll stick it. I guess the default is 10 to 100. So your smallest degree measures will be of a diameter of 10, and your largest will be of a diameter of 100. So let's just try that out and see how it does. We'll go apply. And you can see maybe that's a little bit too much. There doesn't seem to be as much of a disparity. You can see they got a little bit bigger, but not big enough. Maybe we'll keep that as is. You can see here, but one of the challenges is that we still have too much overlap. So we can play again with the measures here within the force layout. So we have it, we can change also scaling as well. So maybe let's try changing the scaling to 30 and see what happens. Oftentimes what I do when I'm doing a network visualization is I play around with these numbers and I just run some of the layout attributes, and then we might, depending on how things are set up, you might have better results. But I just play around with the numbers. I click run. So that's getting a little bit better. So when I change the scaling, again, scaling here, you can see that there is a little bit more separation now between our different nodes, and we can start seeing networks emerge. And so again, depending, this doesn't stop until you tell it to stop. And again, depending on the size of your node, the amount of nodes, you kind of wait till it appears to be somewhat more useful for the amount of nodes that you have. Let's just stop it for now. But you can see now from this that we have much clearer networks existing. And you may need to play with more of these numbers. You might want to play around with the gravity a little bit, or the overlap. I guess not the overlap, but so that you can still play around with the gravity of numbers a little bit to see if it separates even more. But we're in pretty good shape here. We can now see at least some significant potential influencers in a way that we might not have seen before. So we can see, a lot of people seem to be communicating with this individual. Particularly this person here seems to be a particularly influential account. Again, because this node is now larger, that is an indication of they have more people communicating back and forth with them, because we just do this as a simple measure of degree measure. You can see a few others. There's some here, up here in the corner. So now that we've changed the size of the node and then played around with the layouts a little bit, we can more clearly get a kind of visual sense of what is, who might be influential in this larger network conversation. So you can see that the underlying data of what we have here hasn't changed, but just changing the kind of appearance of the different nodes gives us more information than we would have had without changing that layout. looking at this network graph, we still don't really have a lot of useful information. We have a lot of dots, but we don't necessarily know who these dots represent. And so this is where we will use our label information that we included on our node in our node file. So if you want to see that, by default, it is not visually represented on the network visualization available in the overview tab. But if you want to see it, there's a couple of different options here in the bottom left here. So if you just click on the little T, you will all of a sudden see all of the labels for so this is again the usernames for all of these individuals. And so you can see that this node belongs to this particular handle. So when you look at this, it's not super useful. There's a lot of overlapping. And so you can, again, do a little bit of formatting change to make all of this look less garbled, for lack of a better word. And so the one thing that I like to change is this size mode here. So if you click, there's two A's. If you want to change the size of the individual based upon the size of the node, you can click on the little A and then go to node size. And you can see here now that if we scroll in, the bigger the node, the bigger the text. You might want to play around with the text size a bit so there's a little less overlap. So here we're not in bad shape. We can also change the color as well. Since our nodes are black and our text is black, it's a little bit hard to see them. So we can click on this little color wheel here, and maybe we'll change them to pink. Maybe pink's not a great color. Let's change it to, that's not good either. So you can just settle on a color that works or makes sense. So this kind of purplish doesn't look too bad. And now we can get a sense of who these people actually are. And so we know that, who this dot is, and because we've included this label, we could now, for example, look up this individual and see, who they are and why, and have, do a little bit more analysis on why they are, particularly important. So for example, here you can see that a lot of people are interacting with this, and this is a film company from what I recall. So we, now that we have these labels shown on our visualization, it gives us far more context on who these individuals might be. So again, playing around with having the labels appear, then scaling the labels based upon the node size, and then potentially changing the color so that the color is different than the nodes, gives you, again, a little bit more of a visual representation of who the individual influential people might be. And this often will open up avenues for further analysis. So we know that this person is influential. We may now want to look up them individually on Twitter to see, what is the content that they are, sharing. The final thing I wanted to kind of show in this little workshop series video is how you can split this whole network visualization into individual communities. And so we did a bit of that. When we clicked on the modularity statistic, it essentially calculated the communities for us. And now, because we've done that, we can visually represent that on our network visualization as well. So again, to do that, you would go to this appearance tab. And we're no longer changing the size. What we're going to do is change the color. And then we, again, make sure that it's on nodes. We will click on partition. And then we'll choose an attribute that we want to partition it based upon. And in this case, we want to do a modularity class. You could do it on a few other things, but the modularity class is the attribute that splits them into communities. And then what you essentially see is a variety of different colors based upon the communities that were created. And so the larger, I guess, percentages represents how many nodes or elements are represented in that community. They are essentially given individual colors, and as the numbers get smaller, they all kind of default to gray. But if we apply this by pressing the play, you can now see that the communities of the potential communities represented in our document are now labeled. And so you can see that a community, which is represented in here in pink, seems to surround this film production company. Again, if we highlight here, there seems to be a community. The second highest community is represented surrounding this individual as well. So again, you can see, and this will vary depending on what your data is and how effective it is, but you can essentially now see some communities that have existed. And this can be helpful, particularly, again, with network visualization, you want to see potentially, what communities have formed and how are they, who are they surrounding, I guess. And so in this case, you can see that in this case of this pink here, there seems to be a community surrounding this individual, and it has a lot of people kind of centered around it, but then also some kind of outliers here on the side as well. So just know that you can use a tool like Gephi to also split this, all of these network visualizations into separate communities as well. So there's far more you can do with network visualization and Gephi specifically, but just know that it's a tool that exists, and it can give you far more insight into the kind of network characteristics of how people interact with one another than you could do with manual analysis alone. So again, some of these processes here where we kind of determine who is influential and who all of the communities are, again, would be challenging with a data set of this size, or of the 100,000s, or of the millions. And so just know that network visualization is a tool that it exists, and oftentimes you can use it to illuminate other avenues of research or work. So again, knowing that there is a community surrounding this particular Twitter account, we may find that, let's try and do some more in-depth analysis of, what this individual is sharing and what content, for example, is resonating with them. I often don't, use network visualization for the sake of just network visualization. It often illuminates areas of research that might not have been, known hadn't you used an approach like this. And again, we will have some more links related to Gephi on our website if you want more information about the tool.